Welcome to the Tech Blog Writer Podcast, your guide to future tech trends and innovation in a language you understand. Now, over to your host, Neil Hughes.
Welcome back to the Tech Blog Writer Podcast, and a big hello to Chris Hutchinson, who doesn't say where he's from, but did say, Neil, I've heard you say you listen to a lot of podcasts, even more than music playlists now. But he said you did go to Glastonbury recently, so I know you still like music. Can you share with your listeners the kind of music that you like? Wow, Chris, man, I'm going to open myself up to ridicule here, as music is quite a subjective thing, isn't it? But I'll be completely transparent with you. My favourite band is The National, and I'm also blown away by the talent and intense performance of Sharon Van Etten. I think her album is so far my favourite of the year, especially the track 17 on there, which has also got a great video too. Elsewhere, I'll give you a little tip. If you go to YouTube and look up a song called My Honest Face by a band called Inhaler, as soon as you hear the vocals, you're going to think to yourself, this sounds like you too. And there's a good reason for that, because it's actually Bono's son, and the video is shot by Noel Gallagher's daughter. All that makes me feel like I'm getting old. I'm actually watching the kids of the band I grew up with now. But it does seem that they're really trying to play down the U2 thing and make it on their own. And they're touring the US and the UK this year, and I've seen tickets in the UK for only £8. Luckily, Jay Mumbar, my good friend, has picked me a ticket up, so it's a great time to see them before the hype machine kicks in. But just looking back at the bands I've mentioned there, it's quite amusing to think that I'm a happy-go-lucky guy, but a lot of the music I listen to is quite intense and melancholy, so I don't know what's going on there. That's a topic for another day. So before I turn this into the Music Blog Writer Podcast, we better get back to tech quick smart. But thanks for your question, Chris. Now, today's interview has it all. We've got stealth startup, ex-Googler, ex-Apple guy, 3D printing, and a mission to reinvent manufacturing as we know it. Because a San Francisco-based company called Origin that was founded by Chris Prucha, ex-Apple, and Joel Ong, ex-Google, they had a vision to change manufacturing as we know it by making 3D printing, or additive manufacturing as it's known in the world of manufacturing, and viable mass production. Essentially, by leveraging the powers of mass computation and mass connectivity to the opportunity to make parts, they are aiming to help manufacturers build better products, but at a lower cost, more sustainability, and help get products to undeserved remote places throughout the entire world. So, want to find out more about how technology is about to change the world? Me too, that's why I get out of bed in the morning. So buckle up and hold on tight so I can beam your ears all the way to San Francisco so we can speak with the co-founder Chris Prucha, who's going to tell us all about Origin. So massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
My name's Chris Prucha. I'm the co-founder and CEO of Origin. Before this, if we go way back, I'm actually from the Detroit region of Michigan, born and raised there. So Michigan beginnings, and I moved to California about now a decade ago to work for Apple as a software engineer. And I worked there. For a few different years on many different projects, from Apple.com to internal retail systems. I got to work on a really interesting project. Unfortunately, Steve Jobs passed away, and we made this very interesting follow-up tribute for him. And so I got to be the lead engineer on that project. After that, I started a company which became later known as Notion. So Notion's sort of this, what it is now is very different from its humble beginnings, but it's a sort of almost like a collaborative workspace, kind of like Evernote meets a wiki, kind of the other half of Slack. How Slack's more for communication, Notion's more for storing knowledge. I joined that team after leaving Apple very early on, and we built this product. And now that product's used by millions of people. And then after that, I got, because of my Michigan background, was very interested in just re-entering what I call the physical world, not just working on software, pictures behind glass, but working with my hands again, doing something real. And the thing that I find really interesting about 3D printing, which I'm going to keep saying 3D printing or additive manufacturing kind of interchangeably, is that 3D printing is really the closest thing we have to programmable matter, where it's software meets the real world, where you can actually program something to create something very, very directly. And so I was very interested in this whole concept, and I actually got interested in this concept at Notion because we were doing a lot of research on computer, sort of the history of computation, and some of the research that had been done early on, around programmable matter and different ways of doing computation. So interestingly, that's what got me very interested in 3D printing.
And I think a few keywords there that set off my text by sensors. So I feel like there's a great story of how you came from Apple, and your ex-Google co-founder, Joel Ong, had this vision to change manufacturing as we know it by making 3D printing. So I've got to explore that a little bit further. I mean, can you share the story of how you two met, got together, and what essentially put you on this path?
Yeah. So we'd been friends for a while. When I was actually at Notion, we worked on some open source projects together, and I think this is really where one of the principles we'll get back to as we discuss, but this principle of openness stems from. So in the software world, you have open source software, you have open software that you can just build upon, and really that was the premise of me working with him, and he worked at Google X, and he worked on Glass, and he worked on projects that I don't even know what they are to date because they haven't been published. But he also worked on Chromium, and Chromium is kind of the project that backs Google Chrome, and it's a huge open source project. Apple didn't start it, but Apple has a project that Google adopted that became Chromium called WebKit. He was officially working on Chromium, and I had done some work on WebKit. And, this is a very, very interesting open project of all of these companies that are normally competitive, collaborating to essentially build this open web. And it's just being involved in that early in my career, and I think Joel being involved in that early in his career, exposed us to entirely new business models. And so when it came to starting Origin, he was still at Google, making the Google salary and the Google perks. And, I had left Apple, and at this time I'd left Notion, and I started messing around with 3D printing technologies, mostly, desktop, consumer grade printers. Most of those are kind of your MakerBot type, where they extrude plastic and you get this really low quality product. But there was this new type of desktop printer in the Formlabs Form 1, which uses a liquid resin and creates a higher quality product. It's still kind of rough. And there's a company here we'll say is local. It's called Autodesk. And they actually were working on a new type of this liquid resin printer that, unlike the Formlabs printer, this printer was actually fully open source, and it was called the Autodesk Ember. And it used a more advanced technology at the time, DLP, which is very uncommon. And it produced these just extraordinarily high quality parts that are just indistinguishable from injection molding. There's a lot of issues with the process. The materials were terrible. They're very brittle. You drop these parts, and the magic would be gone, and because the parts would break, and the printers weren't that reliable. But the great thing is it was open source, and so I was actually able to hack it to make it do a lot of very, very interesting things. And Joel kind of helped me do that along the way. And because I've been in the startup world, I was really interested in working with hardware startups. And one of the issues hardware startups have is bringing a product to market. They normally they would 3D print a product and it'd look very rough. And sometimes they would, kind of dress it up and paint it. And you do all this processing to it to try to get a looks like prototype. And then they basically have to bring the product into production. And it goes through all the EVT, DVT stages, et cetera. I thought, why can't, and this is very naive of me, I thought, why can't hardware be a lot more like software we build at Apple and Google, where I can make a prototype of some software, press a button, and we can launch it out into the world. And if it doesn't work, we can do it again and again and again. And we can do things like split testing and if 5 years ago or so, I think this was an incredible approach to develop software. I think the tech industry may have gone too far with this type of optimization, how powerful software is. So the idea was, how do we do this with hardware? And the logical answer was with 3D printing, but it had to be good enough, to be able to print a real end-use part. And I was lucky to find a few startups, and one of them was actually a blockchain startup called Chronicled, who I was able to work with early on to 3D print prototypes, where the goal was to print enough prototypes that they could actually ship the final product. And this was sort of an impossible task that I just thought was very interesting. And I had worked on it and basically produced all these prototypes that weren't good enough, and it would take a few days to produce, print a prototype. 3D printing tends to be very slow, especially back then. And through a lot of software upgrades and tinkering with the Ember, I was able to output a product that, when put in front of the CEO and the investors, they thought it was good enough, and that was very interesting. And as soon as they thought that the product that printed was good enough, where I could only make a couple per day, they got a contract with Marshawn Lynch's Beast Mode. So he's from the Seattle Seahawks, NFL star, to produce these sort of blockchain-enabled apparel tags for one of his lines of footwear that was limited edition. It was going to go out the door. And he wasn't happy with the design of the apparel tag. And so, just the classic startup story where you have this, funded startup that has this big contract, and, they're not able to deliver the product that they had promised. In this case, it's this apparel tag, because Marshawn wasn't happy with it. The CEO begged me to produce a prototype to show Marshawn that would please him. And after about 3 days, we did created this prototype, and it took 3 days to create it. And they ended up showing it to Marshawn. He loved it, and he just expect that 2,000 of these would ship in the next week or so. And that's really the founding story of Origin. Because at that point in time, Joel wasn't really working with me. He was working at Google, and I was working on this. And I think I went a little bit too far, where I got very serious. And one day I told him, I said, Joel, I don't know if this is a company, if we're building a product or what, but we have the opportunity to 3D print something that is so high quality that the end users, don't even care that it's 3D printed. They want it because it's the right manufacturing method. And I said, that's revolutionary. The problem is that we can only make about one every 3 days, and that's not very fast. And so you need to quit Google and work on it full time with me, because we need to make 2,000 of these. And he did the logical thing, quit Google. I think he had some blowback from that. And we started working on scaling up the production of this product line in 2 weeks, and that's a story in itself. And that's how the company got started.
What a story. And of course, Origin came out of stealth late last year, and you recently unveiled your new commercial grade 3D printer. But can you tell me more about the release, and how's it been received? And I suppose, has it all been worthwhile?
Absolutely. So, when I started with the sort of humble beginnings, that was, 4 years ago. And we ended up shipping these apparel products the 2,000 of them, they weren't as high quality as the prototype. In the last couple of days of the production run, we had this huge breakthrough with software when Joel sort of took over, creating the software that was now running this 3D printer and orchestrating the manufacturing workflow. And we ended up recreating 2,000 of these apparel tags in just a couple of days. And those are what shipped out to customers. And really what we realized, there was a few things from the very early days that were just really core principles to what even made this possible 4 years ago. One is we had the Ember was open. So we worked with a local material provider and made a unique material. Two is we realized software in 3D printers is very primitive. People think this stuff is like the Star Trek replicator. It's not really. But we're able to write really, really great software. We're both software engineers. We're able to run it on modern platforms. And we realized with this type of print technology, we could write software that was able to modify not just the print process, but how we orchestrate a large number of printers. And in this case, how we even do the chemical reaction with the material to create really, really, really great surface finishes. And we sort of did this very early on. And then we collected a lot of data from these printers, even in the early days, because that's how we knew how to improve the process. And so from the very beginning of Origin, we kind of had this understanding that software is so powerful in 3D printing, and it's underappreciated. Openness is really powerful. We could work with anybody we wanted to. We didn't have to work with one material vendor. We could work with this company locally. And three is that if we had data, we had information, we could really rapidly iterate the process. And our company stayed in stealth 4 years. And the reason we did that is we didn't have a business model. We had this proof of concept where we're able to scale up this apparel tag production. We extended it to other lines. We ended up building kind of a factory here. We ended up modifying these Autodesk Ember printers and started to really build on the software component. And then Autodesk killed the printer. And it's not a printer you want to do manufacturing with. It doesn't print very large objects. We had to hire somebody just to rebuild them all the time. It's really a consumer type printer. And when this happened, it was right around the time that we were raising a proper funding round for Origin. And we're able to get, probably familiar with, Tim O'Reilly from O'Reilly Media and Joe Montana. But our lead investor, Floodgate, Mike Maples, who was one of the first investors in like Twitter, Lyft, Yasny, companies like that. When we took the seed money from their venture, I had to tell them that we had this great software platform, but there's really no 3D printer out there from a hardware standpoint that will work with our software. And we talked to competitors and HP and others. They really didn't want to work with us. And we realized there's a lot of room to innovate in the hardware, and we weren't hardware guys. And the thing I loved about Mike, who's our lead investor, is he just really believes in companies that have high potential energy. There's a lot of potential, but there's a lot of risk. With us, the risk was we didn't build hardware. No one would accept the use of our software because it was pretty invasive. It would require replacing whatever that company built. So he invested in us, and we ended up hiring a lot of people from the Autodesk Ember team after they closed the program. And we started the development of our first printer in-house. And that printer we designed as a development platform. We realized as an open platform, people would build on top of it. They'd build new software. They'd build new materials. They'd build new hardware. And materials were really important because they've traditionally not been good enough in additive manufacturing for many applications. And so our first printer was really tailored towards material development. And we ended up shipping this Generation 1 system to a lot of small material partners. And this was in 2016. And then until we announced the Origin 1, we actually ended up developing 3 generations of printer, both the hardware platform and the software platform in stealth. And we have customers, when we announced Origin 1, we already have had premier customers in automotive and footwear and the U.S. government and many other sectors that are actively using the sort of the Generation 2, the pre-Origin 1 printer for production. We have BASF, biggest chemical company in the world, Henkel, DSM, and 10 other material partners, all doing formulation and development on a material development version of that Generation 2 printer. And we realized that we had made so much progress with these partners developing new materials, and we'd made so much progress getting some customers' products to close to market, that we really wanted to share what we had built with the world. And to do that meant to take everything that we had learned and basically wrap it up into our third generation product, which we call the Origin 1. And we announced that at Rapid. And it was from us, it was a huge success. Our marketing team is relatively small. We had over 1,000 leads, and we're not trying to sell a printer on everyone's desk. We joked we got like 25 to 30% of the Fortune 500, executives and teams interested in the Origin 1 as a production technology from that one event. And then we're able to, it's really great when you work on something for 4 years and you're quiet about it. And we're kind of accidentally quiet about it. We just didn't have a marketing team, and we really cared about developing the right platform and product with our customers and partners that worked before talking about it. So something about the launch just felt was really motivating to the team here at Origin to finally show off their work and show off, what we believe is a new point of view entirely in 3D printing, which is this, this true openness, this true ability to collaborate, but also having a actual technology that can 3D print parts for many applications at mass scale. And that's important. That's super important. If the technology doesn't actually work, it won't go anywhere. And so we felt like we were ready, and we feel like it was really, really well received. We got a lot of press mentions. We really focus on a lot of the trade journals and the articles that are read in our industry and by those that make purchasing decisions on these types of technology as well. So it was really overwhelming. And most of us, after a week or two after Rapid, we all took a week-long vacation. So, our first vacation in many years. So that's basically how the launch went.
Was that a crazy vacation or a relaxing vacation?
For me, it was more of a relaxing vacation. Yeah. I think everyone took different vacations. But the thing I really wanted to highlight was, when you're building a company, startup like this, an event like Rapid for us, we're not going in there small with a small booth, small presence. We have to go up there and, we're a 4-year-old company. We're really showing off this relatively mature product. And, we have we had this large presence. We had this large booth. We have this actually large, nearly 40-person team now. And to do that all for the first time is almost kind of scary, right? It's you're out there with companies that compete with you, and you're showing off what you've been working on for the first time, and everything is new. Designing a booth is new for us. Doing a trade show is new for us. Interacting with the media in many different ways is new for us. The Origin 1 was new for us. The ones that were at Rapid were built the night before in San Francisco and overnighted to the show. And just everything comes in hot, super hot, and it's all new. It's like the creation of a planet. And I think when we ended that and we all took our vacation, we realized, what a success it was, because of just everything came together at the last minute. And there's so many things where it might not have happened, where things might not have came together, not just the show, but the entire company. And so I think definitely it was an emotional event for a lot of us here, and it was a lot of fun.
Well, I'm glad you mentioned the problems around scaling a moment ago, because yes, there are a lot of 3D printers on the market at the moment, but 3D printing so far has not been sufficient for making parts for businesses at scale. So how do you approach a problem like that, and how did you overcome that?
Yeah, this is really born out of the fact that we kind of started in the opposite way that you see a lot of 3D printing companies being started. So a lot of 3D printing companies, they go out and they have a new technology and they apply it to 3D printing, or they have a new 3D printer. What we started out, in the origin story of the company, no pun intended, is we were trying to figure out how to 3D print these products, or 4 years ago, and basically we were trying to figure out how do we make these products like software, where we can rapidly change the design and test them without making molds. And 3D printing seemed like the right answer, and we had to figure out the technology and software to do this. And I think naturally the problem was solved because of the flexibility we had in the beginning, where it was, we're just solving the principle of the issue. Let's 3D print an apparel tag and be able to change its design, and customize its design. How do we do that, right? What's involved? We don't have to worry about the business model. We don't have to worry about making money. And really we found out that there's a few core elements to this. I think one of the most important ones that's really underappreciated is materials. So most 3D printing companies aren't material companies. When one of the issues with scaling 3D printing is the cost. Even in traditional footwear, approximately about half of the cost of the BOM cost of your footwear is materials. And you're talking about very commoditized materials. When you see these 3D printed shoes and they're $300 or $400, well, a big reason for that is because the cost of these 3D printed materials are very expensive. And so by working with an open network of companies and giving them the right development platform, we've really focused on a few things. One is making better 3D printed materials, because most of them just they were definitely not good enough 4 years ago, and they're still improving all the time. But two was to get the economies of scale that some of these big chemical companies are capable of doing, to drive the cost of materials down to where it's even viable to produce a 3D printed product. And this goes without talking about the platform and the hardware or anything else. Just the viability of having the right material at the right price point is a go or no go for any company. In most industries, let's say like footwear, and so that's why we were so focused on materials. And we realized that most people had this HP an inkjet model, and I don't really call out HP here, but they created this, or the Gillette razor blade model, where they really make money on the materials, and that's how the 3D printing has worked to date. And that's worked because these companies are using it for prototyping. If it costs $1,000 to prototype a part, that's not bad. If that part needs to cost $5 to make, well, the economics just don't make any sense. So we realized a few things. By having an open network, these companies would essentially they're in a competitive marketplace. If a footwear company needs a less expensive material, they're able to choose a material provider that meets their requirements. And those companies are competing with each other, right, to get at the right price point. That's important, and that's going to become more important over time. It's the standard marketplace effects we see in business. Two is that Origin is fully neutral on materials. You probably have seen things with the App Store where, if you sell on the App Store, you pay Apple kind of a flat fee. Really, what's happening in 3D printing is if you, let's say you rebrand someone's material, people are getting different sort of kickbacks and it's not consistent. But on the App Store, Apple gets a percentage of the revenue, but it is generally flat, as far as I know, flat across all developers, kind of levels the playing field. But there is this issue where Apple, they can prefer their own music playing app, Apple Music, over Spotify, and I know there's some litigation over that right now. And it just shows some of the holes in the idea that if you kind of have a vertically integrated solution, or you're making things that are competing with your partners, it causes a lot of issues. So we call ourselves fully neutral. So we're not just open, we're neutral in the fact that we don't take any revenue from the material partners when they sell their materials. And that leads to a lower cost material to our customers. So right now, if they're able to, if they get materials from a company like BSF, right, it's less expensive for them to get those materials on the Origin One, whether or not they're available for other platforms, because we don't accept any of any royalty on it. And this is just the material component of really what you need to do to scale. On the hardware and software side, on the software side, we've built this cloud infrastructure with really great engineers here in Silicon Valley. And, they've built scaled solutions that have scaled to millions and billions of users before. And, we believe we can do that here. We can protect data, the design files, things like that. We have an on-prem solution as well to take basically the cloud and make it local for some manufacturing operations. We believe that software platform is inherently scalable because a lot of the people that are working on it here have done it before in other industries. So scalability of software is actually a concern. You have to manage a very large manufacturing operation in the end here. A lot of inventory, a lot of parts. You need integrations with different pieces of software. And then finally, there's the scale on the hardware. For us, it's very simple. We believe that scalable hardware means that you scale in parallel. And an analogy I like to use is the difference between the CPU of a computer and the GPU. And so, a CPU kind of does things in a sort of serial way, processing one thing at a time. And now we have multi-core CPUs that speed that up. But the GPU sort of does more specialized tasks. But instead of having 2, 4, 8 cores like an Intel processor has, these NVIDIA and let's say AMD GPUs, they have thousands of cores. And this allows them to do 3D graphics in a way that a CPU can't do. But it also turns out it allows them to do AI in a way that a CPU can't do, and do all these scientific calculations. And so now you have companies like NVIDIA where they're using essentially this GPU technology for a whole host of applications just because of the fundamental way that it scales. It scales in parallel. You have lots of cores on one GPU, and then you can have many GPUs in one system, and then you can have many systems networked together. And this is how we think manufacturing will look like in the future. So the Origin One is designed to work in a fleet of systems. So you never really have one at a time. You have 3 to 50 of these systems, and you orchestrate them. All the systems know about each other. One person can run 15 to 20 systems. You don't need robotic automation. Robotic automation is really cool. I think maybe when you have 50 to 100 systems, you need that. Well, you have these other 3D printers that are more like mainframes, more like the CPU, where you need multiple technicians or one technician to run one printer, let alone 50 of them. So they're thinking about robotic automation to be able to scale those systems. So that's how we think about scalability. We think about it has to be modular and parallel. Our systems are very high throughput as well, so they print very quickly. One of the noted things that we showed at Rapid and also the Origin One introduction video was the quick post-processing. So there's some parts, and we had this movable chainmail that we were showing at Rapid, and it printed in 8 minutes, and it could post-process, and basically as little as 30 seconds to 1 minute. And if you look at competing solutions out there, it may take 8 hours to print. And if you look at some companies, I'm not going to name who they are, but there's a company that would be able to print this relatively quickly, let's say in an hour or two. But actually, it requires a very long sort of post process where once it's printed, it looks like the parts. It then has to go into this thermal bake and all of this post process that adds time and complexity and cost and reduces the yield of the part. And we think that inherently those processes aren't scalable because to really need to make them work, you have to automate them all. And it adds cost, and all that incremental cost you're adding increases the cost per part. So we've really focused on, like I said, that mass parallelization of the print process, high throughput, and removing a lot of these post-process steps. And coincidentally, to pull everything together, this is how we were originally able to scale the products we were printing 4 years ago, like those apparel tags. The first versions, we had a lot of post-processing. By eliminating the post-processing, we were able to get a lot more throughput out of the systems. And to be able to print more, we added more sort of printers to the network. And so this is how we think that scale works. And it really is important that when you manufacture a product, you understand what the cost per part should be in terms of how much it should cost to produce. And we can very quickly figure out if the Origin One with a specific material will be able to do it, within a certain cost target very accurately. And those costs are coming down all the time, principally not through the cost reduction in hardware or throughput, but because of the cost reduction in materials. As the scale of the materials goes up, you get this classic economies of scale like you saw in the oil industry, where the cost to actually produce these materials comes down, which makes me really excited about not just the scale of our system, but the idea that 3D printing is a viable manufacturing method, and we're right at the cusp of it being viable for many different industries. And for example, right now it's taking over dental. Most dental labs are using 3D printing because it makes economic sense at this point. I think that trend will continue. And I think that 3D printing, additive manufacturing won't replace all of the $13 trillion manufacturing market, but I think it'll start taking bigger and bigger chunks out of it. And right now, it's sitting at a $10 billion market, this little idle market for prototyping. And I think in just the next 2-3 years, we're going to see big chunks taken out of manufacturing, where you see a lot of parts now 3D printed. And I think that's really exciting.
And you did mention a few moments ago about working with leading shoe brands. So I think it's worth highlighting that you did recently announce a partnership with one of the world's leading shoe brands. I mean, is that something that you can expand on today and maybe help people listening visualize how your technology and 3D printing can actually redesign the entire supply chain as we know it?
Yeah. So we announced the partnership with Echo, multi-billion-dollar footwear brand. The thing that we're really excited about with Echo in general is, and it really goes back to what we're trying to do here at Origin, which is, really solve problems for the customer, really solve problems in manufacturing, and I think you see a lot of 3D printed shoes. Something just came out from New Balance. One came out from Adidas, Futurecraft, but 2 years ago, from other companies. And those shoes are really about the future. They're really about the design and what you can do with 3D printing. And the volumes are very low. And these shoes cost $300 or $400. And they're really cool. And we have materials and we have partners that are printing products like this all the time. And they're really, really, really exciting products. Don't get me wrong. But my concern with where 3D printing has gone there is it's sort of like this concept car where like the hydrogen fuel cell car you had in the 90s, where you're showing the future and it works, but it's kind of too expensive. And in the end of the day, there's a lot of disadvantages to the materials or design techniques that they've chosen. So there's a lot more work that needs to be done. And then right after the hydrogen fuel cell car, the thing that actually sort of worked and really had a huge advantage was the hybrid car, right? It sort of took the practicality of the internal combustion engine and added the efficiency of electric motor. And today, really, we see electric cars as the future of transportation, not hydrogen fuel cell cars. The thing we're excited about with Echo is that they are working on essentially with us, not on a footwear concept, something that we're a new design that we're going to launch together to show off Origin. We can't get into very specific details. Those details will be announced in the coming weeks, and we're really excited about it. But it's more about what I would say as a revolution in manufacturing that is broadly applicable across all of footwear. And I think that is the most exciting aspect about this partnership with Echo, is that essentially that we're helped together with them. We're reinventing the entire manufacturing process for footwear, and we can't wait to show the world the results of this, because the results of this are, we don't think this industry will be the same again. We think it'll be a very, very big shift. It's also going to be very high scale, right? So we're talking about the feasibility of printing millions and millions of parts, or producing millions and millions of parts very economically, very, very rapidly. And we think that most people they'll be kind of sidelined by what we'll be announcing with Echo, and I think in the next just couple of months. But we did want to take the time at Rapid to announce the initial partnership with Echo, with the Origin One, so that they are our core footwear partner that's going to be using the Origin One in production. And yeah, it's hard to hold back and talk about how really exciting, how cool of a just really how exciting this program with Echo is going to be, that we're going to launch this year.
It really does sound incredibly exciting and incredibly cool. And I must admit, as a tech guy, I need to get my hands on a pair of 3D printed shoes quick shop. But as you continue to improve the speed and flexibility for hardware design cycles, do you think eventually we're going to start seeing the same type of agility that we see in producing software?
The answer is yes. And I would argue that we are already basically there. As a company, we made the decision in Origin that we would do rapid hardware iteration. That's why we're at our third generation of systems. Our systems have a lot of 3D printed parts. It's sort of one of the almost cliche. A lot of consumer printers, they 3D print their own parts. Our printers for manufacturing, we 3D print a lot of the components in the printer itself because it's the right manufacturing process. That also means that we can rapidly change the design in the printer. It makes it much more modular. And so we've worked a lot flexibility in hardware and design cycles. The other thing that we did is we built an electrical system into the Origin One. It uses, and I talked about those NVIDIA GPUs before and how powerful they are, just in terms of performance and scalability. We made the decision to put a really high performance computer and GPU, happens to be from NVIDIA, that we kind of quietly announced at Rapid, but didn't mention that NVIDIA was a partner very loudly. They are one of our partners. So every Origin One has this really powerful computer in it. And it means that when you roll out a software update to it, you can enable brand new material chemistries that you couldn't print before, and you can increase the throughput of the printer. We have examples with one material partner where just while they're doing R&D on a formulation, they're able to go from printing this material that is truly good for end-use production applications, about 50 to 75 millimeters an hour, which is actually incredibly fast for a production material. You'll see companies out there that print at 500 millimeters an hour, but when their production materials actually only print at like 20 to 50 millimeters an hour. And you can look up what company I'm talking about. And through optimization, the development partner was able to print at 300 millimeters an hour, and they're using all of the sensor feedback in the Origin One. It has basically thermal imaging, so you can look at the chemical reaction that's occurring. It has cameras and computer vision in the system, and it's using that really powerful NVIDIA GPU to process all this data and allow these companies to analyze it in real time, and then it allows them to have a data scientist to really go in depth. And this is really what I think just blown the doors off of optimization. So we can now optimize materials and optimize part geometries to print incredibly fast and reliably. And this is really how we think about making hardware flexible. Not just iterating hardware, but getting to a very, very basic hardware design that is so simple that, in the end of the day, the software matters the most. It's like, my iPhone. It's just a rectangle with a piece of glass, right? And we get excited when new iPhones come out, but now they're fast enough and they have a lot of sensors on them. And it's really the software, right? My iPhone broke yesterday, and I realized it's just a black rectangle, right? Without the software, it doesn't do anything. The software is everything. And this is how we think about just the adaptability and flexibility with 3D printing hardware going forward. It's really going to be all about the software. And the great thing about really achieving the agility of software in terms of the progress of 3D printing, in terms of developing new materials, we think that materials are now being developed a lot more like software. They're able to material companies are able to develop lots of formulations and test them very quickly, print them. We're able to develop changes to hardware and software updates to hardware that change the print process, change the types of chemistries and materials that are used. And then we're able to change software that changes the types of geometries and parts that can be printed reliably. And a great example here is, normally when you 3D print a part, you might need something called a support structure that you have to remove later. And it really increases the cost to print it, and it makes it adds a lot of labor. But through a lot of software optimizations, we're able to generally remove a lot of these things called support structures, so you can direct print a part. And we can print parts with very large overhangs through a lot of these optimizations, again, in software. And I think it's really realizing the vision of, we're getting the flexibility of software development, but not just in the product that's coming out of the printer. That's one thing. You can customize everything that comes off the printer. If it's in dental, or if you're customizing, there's a custom serial number or design on the product that's coming off the printer. That's sort of the low-hanging fruit. We're finding that we're getting materials developed at sort of the speed of software, and hardware developed at the speed of software. And it's really because we're sort of converting the complexity that normally would exist in chemistry, or the complexity that would exist in hardware development, mechanical design, electrical engineering, and really taking that complexity and making it programmable, so that complexity exists in the software. And then a computer programmer, or anybody that can program, can make the system more flexible and more adaptable and more agile. And we've gone a long way over 4 years building this platform. We've even, when you program our printers, customers don't need to do this, but we have a lab team, and usually they use tools like MATLAB and Python. It's very different than the programming languages that software engineers use. Our platform allows academics and scientists to actually program sort of in the way that they're used to. And by doing that, they're able to take full advantage of doing research on our platform, and really advance, material science, or advancing the additive manufacturing process itself. And it's really cool to see all of this come to life. And it's really just a testament to how powerful software is. You only need to build it once, and once you see how powerful software is, It's really about making it accessible, right? So you don't want software to be powerful and only be programmable by a small number of people. You want it to be as easy to use as possible for everybody that's going to be using the product. And so that's sort of our goal right now.
And it really is like an incredibly exciting time for you guys at the moment. I can sense the excitement around the shoes. But what is your grand vision for Origin, and how long do you think it will take you to get to where you ideally want to be?
I think, the grand vision for Origin, the number one thing that we wanted to do in this industry was show that additive manufacturing was viable to produce consumer grade products. Not just some of the stuff you see that's happening in dental and things like that from companies like Align Tech that makes Invisalign for specialized applications. We wanted to show this is a viable medium, and that was really the original goal of Origin. It's not really a grand vision, and when we really dedicated our lives to building this company, the grand vision for it is to build. What we really want to build is a true open neutral platform for manufacturing, because we realize that if these principles that will make additive manufacturing work, they have the ability to change manufacturing, something that hasn't really, manufacturing is more of a macro. It's a huge collection of a lot of different technologies, a lot of different trades, a lot of different even cultures are involved in manufacturing. And we realize that with additive manufacturing, if these systems are networked together, there's this inherent power that these systems have with manufacturing, where they could transform supply chains. You're talking about the fact that it doesn't make sense to manufacture something in another country anymore when you can manufacture it locally. And that doesn't mean bringing manufacturing back to the United States. That means no matter where you are, manufacturing may be more local, because that just makes more sense. The fact that these systems are networked, they're sharing information about how things can be improved, how supply chain, it can inherently track supply chain. And so there's all these challenges in manufacturing that we've sort of inherently solved by building out the Origin One and its platform. And if it was widely adopted, we think that it'll have a really, really profound effect on manufacturing. And we know that. We know that there's other companies that are building other types of platforms with different ideologies that are also networked and connected systems. And if they win, those platforms win, they'll have the same impact. My analogy here, it's like the computer. Back, when Microsoft started dominating everything, you had Apple and Microsoft, and you had this open source movement, right? And Microsoft dominated everything in the 90s because desktop computing was so powerful. We think that additive manufacturing right now is at the tipping point that it's so powerful that there could be a small number of companies that could dominate this, and it'll have a profound effect on manufacturing. And we just believe this to be true. And that's not the grand vision of Origin. That's just what we believe to be true. So the grand vision of Origin for us is to build the truly neutral open platform, because we believe that we don't want to be like, we don't want another 90s where you have one company like Microsoft that controls all of additive manufacturing, especially as it grows, that builds everything themselves. That's really vertically integrated. They may have partnerships, but they tend to, steamroll those partnerships and force them into these marketplaces that don't make sense. If you remember Netscape back in the 90s, what happened there? Netscape was on Windows, but Microsoft was able to bundle their own browser and basically destroy Netscape. We see 3D printing companies doing that today, and we think that's scary. Because in a world where additive manufacturing becomes one of the means of production, maybe a principal means of production, or even 5 or 10% of the means of production for goods, we don't want one company to control that. And so it's really important to have a truly open and neutral platform. And we believe Origin is the only company that has dedicated, ourselves to this type of business model. It's a difficult model to accept as a company. We had to build the company around it from ground zero. We can't make materials, for example, because we have to accept the fact that our margins are lower, but that's fine, because in the end of the day, what we really count on is the fact that software is very scalable. Chemistry development is very expensive. So if you're a company and you're in traditional 3D printing company and you're developing a new materials, and you're used to very high margins, it's very hard to get away from that type of model. So it's a long way of saying that the grand vision of Origin is to ensure that an open neutral platform is the winning platform in 3D printing. And then it's also sort of a warning. We think, we've seen what companies are building going forward, in terms of our customers. We have many customers in different market segments, and we, the evidence, it's the burden of proof is, we think now on other people to doubt that additive manufacturing, won't work. We think additive manufacturing is going, full force, and it's going to happen as a means of production, whether we're ready or not. And it's important that we have a neutral platform. And just to kind of put that into perspective, a few years ago, when you flew on an Airbus A350 XWB, I think 2014 had no 3D printed parts. A year later, had a few 3D printed parts. Now, when you get on the airplane, if it's of the current model year, it has over 1,000 3D printed parts on it. You're talking about an aircraft.
Wow,
just
I had no idea.
Over a couple of years. This is happening, and 5 years ago, you go to you get anything done where it has to go to a dentist. It's very likely done in a traditional way. Well, today, if you get a dental model or you get a lot of this dental work done that's done at a dental lab, it's likely now done on a 3D printer, almost overnight in just a couple of years. And you're looking at entire markets that are starting to move over to additive manufacturing as the principal means of production, and this is accelerating. And I know that there's sexy ones like footwear, but there's the ones that are behind the scenes that are really building up momentum. We think automotive is the next one. BMW announced recently they'd produced over 1 million 3D printed parts, sort of out of the blue, and the momentum is building very quickly. And when you look at just what customers are doing and planning for in the next automotive is a 7-year development cycle. So you look at what they're doing for the next 2 years to 7 years, you realize that this is really happening. And I find that really exciting. And it means that there's a huge opportunity for everybody for platform providers and material companies and manufacturing companies and customers, consumers, to all benefit from what I think is this impending, almost like next industrial revolution where people, aren't really expecting it. It's going to happening silently. We're so convinced of it that our grand vision for Origin is to make sure that it doesn't go off the rails, that it stays neutral.
Fantastic. Well, a huge thank you for coming on and joining me today. I'm conscious we've covered so much ground. A lot of people listening may walk away with even more questions. So can you remind the listeners of where they can find you online, and also contact a member of your team if they're left with any of those questions?
Absolutely. I don't use Twitter very much. I do have a Twitter handle. You can tweet me or DM me, and my Twitter handle's sort of at Chris Prucha. My last name is difficult to spell, so you may want to put that in a comment somewhere. And then it's always possible to send me or someone on our team an email directly. It's not hard to figure out how our emails work. My email's chris@origin.io. If you haven't checked out origin.io, you definitely should check out the Origin one. Some of our philosophy around our material network, open philosophy, There's some cool videos on there as well. That's the website we launched at Rapid. And then for any sort of media contacts, you can contact Finn. And so his email address is finn@origin.io as well.
Excellent. Well, I'll add a video and the links in the blog post that'll accompany this podcast episode over on my website, techblogwriter.co.uk. But I cannot thank you enough for coming on and sharing this great story. And I also loved as well as everything that you've learned from your journey, especially from the browser wars there and not wanting to let history repeat itself. And like you said, it is revolutionary tech. And for me, it's going to redesign manufacturing as we know it, which is incredibly exciting. But more than anything, just a big thank you for coming on today. Thank you.
Oh, thank you so much. This is the first time that we really got to share this story. So there's just a lot of stuff to share. It's almost a little bit emotional because it's been a long journey, and it's been a pleasure to share it with you and your audience.
Now, I know today's episode was a little longer than usual, but man, what an amazing story. And back in May, Origin unveiled that new commercial grade 3D printer. And they've also recently announced a partnership with one of the world's leading shoe brands in Echo. And you could really sense the excitement oozing out of Chris. And I just got this strong feeling that there was so much more to come that he was having to hold back from revealing. So I advise you to follow them on Twitter, etc., because I've just got this sneaking feeling that there are incredibly exciting things ahead. All I ask, though, is you remember where you heard about them first. But if you're working in this space and have something to add or just have a question to ask me or anything at all, remember, you can email me techblogwriter@outlook.com. Look me up, Neil C. Hughes, on Twitter, LinkedIn, Instagram. But if you do follow me on any platform, all I ask is you just let me know. Just say hello. But that's it for today's episode. So thanks so much for listening and tuning in every day and making it to the end of another episode. I hope you'll join me again tomorrow. But until next time, don't be a stranger.
Thanks for listening to the Tech Blog Writer Podcast. Until next time, remember, technology is best when it brings people together.